Good morning. We're writing notes from writing notes. These are your notes on writing equations from graphs. So a couple of things before we get started. We already know that the a value stretches or compresses the function vertically. Oops. Okay, and the a value is also in charge of reflecting our function over the x-axis. So that would be our rocks. That's really pretty. Our d value is going to shift the function up and down. And the b is the base. And remember that we can find the base by finding the common ratio. The common ratio, r, is the base. Okay. So we have to write the equations for these exponential functions on these graphs. And to do that, we need to find all the stuff that's in this equation. Y equals a times b to the x plus d. So we have to find a, we have to find b, and we have to find d. And we're going to do that in a special order. First, we are going to find d. Then we are going to find b. And then last, we're going to find the a. Whoops. Okay. So it's sort of backwards from the order that they're in our equation, or reverse alphabetical order. It's both. Okay. So to find the d, remember that d is in charge of our shifting up and down. So we can tell if it's shifted by looking at our horizontal asymptote. So our asymptote is going to tell us the d value. So this asymptote right here is the equation y equals 0. So 0 is d. So that's one thing off the list. Now I have to find b. So I'm going to make a table of my points and find my common ratio. So make sure you're picking points that are next to each other. Don't skip. Okay, so I've got from my asymptote 0, 1 and 1, 2. So to go from 1 to 2, I have to multiply by 2. So my base has to be 2. Okay, last thing we need is the a value. The a value comes from our y-intercept. So we have to look at how far our y-intercept is away from the asymptote. So when I look at this y-intercept, it is 1 unit away from my asymptote. So my a is 1. So now I can write my equation. So it'll be y equals 1, because that's my a, times b to the x, so times 2 to the x, that's my b, plus 0, which is d. That's it. Okay, now we're going to do this one. So my horizontal asymptote is the same. It's just on the x-axis, so y is 0, so d is 0. I can find a little table for my points. That was huge. Here's a pretty one. Here's a pretty one. I got 0, 3, and I got 1, 6. So to go from 3 to 6, I'm multiplying by 2, so my base is still 2. Interesting. And then last, I look at my y-intercept and how far it is from my fake origin on my horizontal asymptote, and it is 3 units away, so my a is 3. So I've got y equals my a of 3 times 2 to the x plus 0. That's my B, that's my D. That's it. Okay, so for example 3, we didn't do both of these. It was kind of overkill. It was like way too many. It's like, we get it already, Mrs. W. So we're just going to do example 2B. So first we need the horizontal asymptote. Boop, 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 boop. And that gives us y equals 0 for the asymptote. And that tells us our D is 0 again. Okay, next. I need some points. Oh, gnarly. I think it's this one. That looks like -1, 6, and 0, 2. So from 6 to 2, I'm multiplying by 1/3. So my B is 1/3. Okay. And then last, my A value is how far my y-intercept is away from my fake origin, whether or not it's on my real origin. So it's 1, 2. So my A is 2. So that'll be y equals 2 times 1/3 to the x plus 0. Here's my A, my B, and my D. Easy enough, right? Okay. We're going to do one more, and then we're going to do the big problem. These are going to be short. The kids told me that they didn't need as many as I did, so we're going to do just one less. Okay. So this time, guys, notice that my horizontal asymptote is not on my x-axis. Okay, so this time my asymptote is y equals -3. Oh, we're not going to do this one. We're going to do the one next to it. Sorry. We're going to do this guy. Sorry, we're on 3B. Sorry. Okay, same thing though. The asymptote is shifted down 3 units. So this is the equation y equals -3. So instead of being 0, my D value is -3. Next, I'm going to make a table of points, but I'm not going to go from my origin. I'm going to go from my fake origin, where my y-axis intersects my horizontal asymptote. So y-axis, horizontal asymptote, where they cross. Okay, so from there, I've got this point, and that is not the point 0, 0, that is the point 0, 3. It's not actually 3, but we're going to call it 3, right? And then my other one is 1, 1. Not actually, but we're going to call it 1 so that we can find out what we're multiplying by. So to go from 3 to 1, we are multiplying by 1/3. So B is 1/3. And then to find my A value, I have to look at how far that y-intercept is from my asymptote. So from the asymptote, I go 1, 2, 3. So my A is 3. Okay, so sorry. Y equals my A of 3 times 1/3 to the x. That's my B to the x. And then I have a -3 as my D. Cool. Okay, here we have a graph showing data collected by a scientist in the lab. She's recording the number of skin cells growing in a petri dish. And we have to use per graph to answer the questions below. So how many skin cells did the scientists put in the Petri dish to start? So at the start, at time 0, she had 4 in there, because that's this point right there. So, let's see, 0, 4. So at 0 hours, there were 4 cells, and we know that because this is the y-intercept. 0, 4 is the y-intercept. Okay. Okay, let's look at the horizontal asymptote real quick. This is the equation y equals 0. So that means that our d is going to be 0. So we already have d. Now we're going to make a table to find the common ratio to use as our base. So I've got the point 0.04, and I've got the point 116. To go from 4 to 16, I have to multiply by 4. So my base is 4. Okay, now I have to find my a value. So I look down here at my horizontal asymptote, and my y-intercept is 1, 2, 3, 4 units away from my asymptote. So that means that a is 4. You can see it right there in my y-intercept. Okay, so now I'm going to write my equation. Y equals 4, that's my a, times 4 to the x, that's my b to the x. You can put the plus 0 on there or not. It doesn't hurt at this point in your life. So we need to know that x is the time in hours. I got that because the time is on my x-axis and the number of skin cells is on my y-axis. So when it says define my variables, that's what it's asking me for. Y equals skin cells. Now we have to use our function to predict how many skin cells will be in the Petri dish at 5 hours. So to do that, I'm going to use my calculator, because I can get a whole lot of stuff from my calculator. I'm going to put this in the y equals on my calculator. Calculator, y equals, okay, so I've got 4 times 4 to the x in there. And I want to go to my table. And what I'm looking for is when the time, okay, this is the hours, right? When the hours are 5, I have this many skin cells. And then the next one is, okay, when it's 7 hours, how many? So this is going to be the 7 one. So 4,096 and 65536. I'm probably going to have to go back. So, oops. At 5 hours, there were 4,096 skin cells. And at 7 hours, there were 65536. 65536. So 65,536 skin cells. Okay. And then the last one is asking us if -3 is in the domain. So -3, well, okay, it'd help if we knew what the domain was. So the domain, remember, is our x values. Okay, the range is the y's. So can -3 be an x? So if I look down here and I go -1, -2, -3, can I have -3 be the number of hours in the Petri dish? And I would say, I don't think so, because that doesn't make a whole lot of sense. Well, we didn't have any cells in the Petri dish until time 0. That's when they were put in the dish. So I would say no, because there were no cells in the dish before time 0. No, there were no cells in the dish before 0 hours. And that's your notes. That wasn't so bad.